Hello, grade 8, how are you? In this video, I'm going to answer with you the questions in the workbook that you had as an assignment, exercises 2.2 and 2.3. I will leave exercise 2.4 distance time graph for next week to answer it with more explanations. So, some of you found some of these questions a little bit tricky. I want you to really concentrate now with me as I answer all these questions and have your notebooks open so that you can correct any mistakes and write any tips and explanations. Exercise 2.2 Speed Calculations. Use the equation for speed to solve some numerical problems. A. The table shows the time taken for each of 3 cars to travel 100 meters. Circle the name of the fastest car. Complete the table by calculating the speed of each car. Give your answers in meters per second and to 1 decimal place. So in these 2 lines, you have to pay attention to all the things that you need to complete. The first information that you have is that all the cars are traveling the same distance, 100 meters. So the distance is fixed for all 3 cars. Then you have to circle the fastest car. Then you have to complete the table by calculating the speeds in meters per second and to 1 decimal place. So you have to pay attention to all these points. The first thing we need to do is to circle the fastest car before doing any calculations. How would we know the fastest car before doing calculations? So this is a fixed distance race, 100 meters. All of the cars are traveling the same distance. The car that will take the longest time would be the slowest, and the car that would take the shortest time to cover the same 100 meters would be the fastest. So the fastest car in this case is the one that's taking 3.8 seconds to travel 100 meters. So it's the green car. Okay. Complete the table by calculating speed of each car. So speed equals distance over time. For the red car, it equals 100 meters divided by 4.2 seconds. The answer is 23.8 meters per second. They want the answer in meters per second and to 1 decimal place. Okay, so you don't have to round the answer. And the green car, its speed would be 100 meters divided by 3.8 seconds. The answer is 26.3 meters per second. The yellow car, the speed is 100 meters divided by 4.7 seconds, and the answer is 21.3 meters per second. B. A jet aircraft travels 1,200 kilometers in 1 hour 20 minutes. How many meters does it travel? So it travels 1,200 kilometers. We need to convert this to meters. From kilometers to meters, 1,200 kilometers. To meters, I need to multiply by 1,000. So the distance in meters is 1,200,000 meters. How far or for how many minutes does it travel? Okay, so it travels 1 hour 20 minutes. 1 hour plus 20 minutes 1 hour is 60 minutes. 60 minutes plus 20 minutes. So it travels for 80 minutes. And for how many seconds? So we need to convert the time in minutes, 80 minutes, to seconds, multiply by 60, and the answer is 4,800 seconds. Calculate its average speed during its flight. The average speed is distance divided by time. Now we have the distance. Our distance is 1,200,000 meters. Our time is 4,800 meters. So 1,200,000 meters divided by 4,800 seconds, and the answer is 250 meters per second. Pay attention to the units that you're using. C. A stone falls 20 meters in 2 seconds. Calculate its average speed as it falls. So now I want you to imagine a stone falling from a height. Is the speed of the stone the same or is it changing? So this exercise will show us that as the stone falls, the speed every second changes. That's why we need to calculate the average speed. So the first part of C, we need to calculate its average speed for 20 meters in 2 seconds. So remember that to calculate speed, we need two measurements. We need distance and we need time. If we have these values, we can calculate the average speed between 2 points. So the stone falls 20 meters in 2 seconds. What's the speed? The average speed equals distance divided by time. Our distance here is 20 meters divided by 2 seconds. So its average speed is 10 meters per second only for the period of 2 seconds in which it only fell 20 meters. Now the second part of C says that the stone falls a further 25 meters in the next 1 second. So the next second after the 2 seconds, it fell for another 25 meters. So here notice that the distance has increased a lot compared to the time here. Here in 2 seconds, it traveled 20 meters. Here in 1 second, in the next 1 second, it fell another 25 meters. So the average speed for the next 1 second is different. Calculate the stone's average speed during the 3 seconds of its fall. 3 seconds. So now the speed that we need to calculate is between the beginning of the falling for 3 seconds. We need to know the distance. In the first 2 seconds, it fell 20 meters. In the next 2 seconds here, in the next second, it fell 25 meters. So our distance here now has increased to 45 meters, and the time is 3 seconds. So distance here is 20 meters plus 25 meters equals 45 meters, and time is 3 seconds. So speed equals distance divided by time. Our distance is 45 meters and our time is 3 seconds. Speed is 15 meters per second. What do you notice about the speeds as the time is increasing? The average speed of the falling stone now is changing. In the first 2 seconds, it was 10 meters per second. When the time increased, the speed has changed. It became 15 meters per second. This will bring us to the final part of the question. Explain why we can only calculate the stone's average speed during its fall. Now, if you notice, the speed of the stone is changing. It's increasing, and we call this accelerating. So the stone's speed is accelerating, speeding up. So the answer, because the stone's speed is changing, it is increasing, and we call this acceleration. Exercise 2.3, more speed calculations, pages 12 and 13. So, this exercise has a little bit trickier questions. So, I want you to remember that any word question, if you simplify it, if you put the data that you have in front of you, what you know and what you need to know, you will make it easier for you to answer any question. Remember that in speed calculations, we only have one missing value, and in order to know it, we need to know the other two values. So, putting these values in front of you and telling exactly what they are will make it easier for you. The first question, a car is moving at 22 meters per second. How far will it travel in 35 seconds? So this is a simple question. It's moving at 22 meters per second. This is the speed. How far, the distance, will it travel in 35 seconds? It's spending 35 seconds. So a straightforward question. We have to rearrange the speed formula. Distance equals speed multiplied by time, 22 meters per second, multiply by 35 seconds, and the answer is 770 meters. Eliminate second with second, our remaining distance is in meters. B. A swallow can fly at 25 meters per second. How long will it take to fly 1 kilometer? A swallow is a type of bird, sununu. Okay, so it's flying at 25 meters per second. Pay attention to the units, meters per second. How long means what's the time needed to fly 1 kilometer? Kilometer is the distance. Whenever you have a speed question where you have to rearrange the speed formula, you have to pay attention to the units of speed. The units of speed, meters per second. So any value that we need to put in the formula needs to be converted to meters if it was distance, or to seconds if it was time. So our distance here is given in kilometers. Before we do anything, we need to convert it to meters, because we cannot use different units of speed or of distance in the same formula. So 1 kilometers, we need to convert it to meters, multiply by 1000 equals 1000 meters. Now we rearrange the speed formula. We need to calculate time. Time equals distance divided by speed. The distance is 1000 meters divided by 25 meters per second. Meters with meters, and the answer is 40 seconds, the time taken for this bird to fly 1 kilometer at 25 meters per second. C. This is the, I think that you found this question a little bit tricky, C and D. So I need you to really pay attention now. I encourage you to draw whenever you have such questions. So drawing makes it easier for you to determine the values of speed, distance, or time that are needed for your calculations. So in C, it has two parts. A high-speed train is 100 meters long. So the length of the train equals 100 meters. Every bit of information in these questions is very important. It's traveling at 50 meters per second. So the speed of the train, 50 meters per second. How long will it take to pass a person standing at a level crossing? We need to know the time that the train needs to pass by a person standing at a crossroad. A level crossing is the intersection where the railway crosses a road. So a person is waiting for the train to pass before he can or she can walk. So time needed for this train to pass this person. If we make a simple drawing of this situation, we would know the values of speed and distance that we need to use to calculate time. We look at the formula of time. Time equals distance divided by speed. We already know the speed of the train. It's 50 meters per second. But what's the distance that this train is going to travel in order to fully cross this person? So we have this person here. He's standing at a cross level. We need to calculate the time needed for a train that's 100 meters long to fully pass by this person. To fully pass by this person means that the train is moving in this direction. The front part of the train must pass by the person until the train reaches the end part, and this end part also passes by the person. So from this point here, from the front part, now the train needs to move forward until the other part, the end part of the train, passes by the person. So the train must be in this situation here. Now the train has fully passed the person. What's the distance traveled by the train at this point? The distance traveled by this train at this point is exactly the length of the train, which is 180 meters. Now we need to ignore the width of the person. It's irrelevant in this case. The next question, we will see that the width of the object that the train is crossing would be more relevant. But we need now to ignore the width of the person. Let's imagine that he's like a thin person. So, to fully cross the person, the front part of the train needs to pass by the person until the end part of the train also crosses the person, which is the distance of the length of the train, 100 meters. So now we have our distance. It's 100 meters. Time equals distance divided by speed. 180 meters divided by 50 meters per second equals 3.6 seconds. Now let's come to the second part. How long will it take to pass completely through a station whose platforms are 220 meters in length? So now the train, the same train, needs to pass by a platform. A platform is the place where travelers wait for the bus or for the train to come. The platform is 220 meters. Let's draw this other situation. Now this is the same train. I hope my drawing is clear. The same train. It's 180 meters long. This train now needs to pass a platform. This is the platform. The platform is 220 meters long. When we say that, how long will it take to pass completely? To pass completely means that the train needs to pass by the platform. This is the front part of the train, and continue until the back end of the train passes the platform. So the train needs to start here at this point. It needs to cross the platform completely. So it has to be now in this situation here. This is the end of the train. It's passing completely by the platform. So it stops here. This is the distance that we need to know. From this point here, as it starts to pass the platform, until it completely passes the platform, so that the end part of the train now is passing the platform. What's the distance here? The distance here is the distance of the platform plus the length of the train. So 220 meters plus 180 meters. It's very simple. We need to calculate time. In order to calculate time, we need distance and speed. The speed we know, it's 50 meters per second. It's the same speed, it hasn't changed. But the distance now is different because now the length of the platform is very relevant. We cannot ignore it. We need to know the distance of the platform. So the train is going to pass the platform completely, so it will pass by the other edge of the platform until the end part of the train passes the other edge of the platform. So now this distance here, the length of the train, 180 meters, plus the distance, the length of the platform, 220 meters. Now our new distance equals 400 meters. Let's put this in the formula. Time equals distance divided by speed, 400 meters divided by speed, 50 meters per second. So our new time here is 8 seconds. And now the last question in this video, which is also a tricky question. I think that you found it a little bit hard to answer. It's not hard at all. All you need to do is draw, know exactly the values that you need to use in order to calculate distance. So, in a 100-meter race, the winner crosses the finishing line in 10 seconds. The runner-up takes 10.20 seconds. Estimate the distance between the winner and the runner-up as the winner crosses the line. Show your method of working. So let's simplify this question. First of all, the race is 100 meters. So this is the distance traveled by all the runners. The winner crosses the finishing line in 10 seconds. Time for the winner who came first is 10 seconds. Time to cross the 100 meters. And time for the runner-up. The runner-up is the runner or the racer who comes second. The time for the runner-up to cross the 100 meters was 10.20 seconds. Estimate the distance between the winner and the runner-up as the winner crosses the line. So, let's draw a simple sketch. Okay. Here's the race. It's a 100-meter race. We have two runners who are going to run a 100-meter race. The winner of the race, he reached the finish line in 10 seconds. So he crossed the 100 meters race in 10 seconds. What's the speed of the first person? Speed of the first runner equals distance over time. 100 meters divided by 10 seconds. 10 meters per second. What's the speed or the average speed of the runner-up during the race? It's 100 meters divided by 10.20 seconds, and the answer is 9.8 meters per second. Now, why did I calculate the speeds of the two runners? And what do we need to calculate? Now, let's imagine that the red color is the situation that the question wants us to answer. He wants us to know the distance between the winner and the runner-up as the winner crosses the line. So now, as the winner crosses the line, now here he's crossing the line. Where was the runner-up behind? The runner-up was running at a slower speed, so he was behind the winner. He hasn't completed the 100 meters race yet. We need to calculate this distance here. What's this distance? Remember, to calculate distance, we need speed and we need time. Okay, so in order to calculate this distance here between these two, we know that at this point, the winner was at 100 meters. Where was the runner-up? At which distance? If we know this distance here, we can take the difference between 100 meters and the distance at which the runner-up was, and we can calculate the difference, which is the distance between the winner and the runner-up as the winner was crossing the line. Okay, so in order to calculate this distance here, what do we need? To calculate distance, we need speed. This is a missing distance. And this is the distance of the runner-up. Remember, this is here the distance of the runner-up. What was his average speed? We calculated his average speed during the race. His speed was 9.8 meters per second. And what was the time when this runner-up was at this point? We said that when this runner-up was at this point, the winner was finishing the race. And at the beginning of the question, they told us that this winner, he finished the race at 10 seconds. So at this point here, the runner-up had the average speed of 9.8 meters per second, and the time was the time that the winner finished the race, which is 10 seconds. Okay, this might sound a little bit tricky. Let's repeat. The question wants us to calculate the distance between the winner and the runner-up as the winner crosses the line. As the winner crosses the line, his distance was 100 meters and his time, and the time was 10 seconds. Of course, the time at this point applies to all the runners in the race. He finished at 10 seconds. So, what do we need to know in order to know where is this runner-up from the winner? We need to know the speed of this runner-up. We calculated the speed, the 100 meter divided by the time the runner-up needed to finish the race, 9.8, and the time is the time at which the winner finished the race. It's 10 seconds. So, this runner-up here would be, we need to calculate distance of runner-up at 10 seconds. Distance equals speed by time. His speed was 9.8 meters per second and the time was 10 seconds. So he was at 98 meters away. So this distance here is 98 meters. Now, we're not asked to know where he was in the race. We were asked to know where he was behind the winner. So we need to know this distance here. So his distance between winner and runner-up equals 100 meters minus 98 meters, and the answer is 2 meters. Okay? Explain why your answer can only be an estimate. Why this can only be an estimate? Because now we are calculating average speeds. So because we are calculating average speed, the speed might change during the race. So our answer can only be an estimate. Why our answer can only be an estimate? Because their speeds might change during the race. Thank you, grade 8. I hope that my demonstrations of the questions was clear. If you still have any questions, I hope that I answered all the questions that I received. I received many questions from you on this homework, and I hope that I have answered all of them. If you still have anything that you don't understand, anything that you don't think that is clear to you, please ask me. I encourage you all to ask your questions on the stream so that I can answer everyone. Everyone would see the question and everyone would benefit from the question and the answer. Still, if you don't feel comfortable to do that, I don't mind receiving your questions on privately. I think that I've answered all the questions. If you still have anything not clear, please ask me, and have a good day, everyone.